So we are discussing the material classification of materials on the base from the material having point of view, and two main categories of material. One is unit load and the other is bulk load that we have discussed so far. Now, the bulk load, we are discussing the bulk load, and in the last class we have seen that as per the IS specification, these bulk materials are being codified depending on their characteristics, and this code, they have been allotted a particular code for that code, and that code consists of actually 5 digits, maximum of 5 digits. You may find that some digits are missing, because so it may so happen because those characteristics are not that important. That is why those digits are not being considered. But basically, it should be a 5 digit code and alphanumeric code. There will be some letters, there will be some numbers as well. So we have seen in the last class what are the how do we feel this particular blocks in this particular code, or rather how do we specify bulk material. The first code that we apply here, that it consists of some alphabets from A to G, which specifies the lump size. So lump size is being specified with the first digit, and the digit can be an alphabet from A to G. How do we specify? Let us see. So this is the classification of bulk material. Okay, there is a table there. Now you see here the lump size. If it is a dusty material like cement, okay, and this is the limit of characteristic. This is the size of the lump. So if it is the dusty material like cement, the code is A. If it is a powdered material like fine sand, it's B. Granular material, grain, C. Small sized lumpy material like iron ore, it is D, and so on and so forth, as you can see. So the first digit, it gives us the lump size of that material. And how do we decide the lump size? Depending on the type of material that we are handling. If it is a dusty material, we put it as A. And how do we define the dusty material? We define it by the average lump size, or the maximum lump size, as you can see here. Okay. So depending on whether the material is dusty, powdered, granular, or perfect, lumpy, these codes are being A, B, C, D, and so on and so forth. It goes on like that. So I have just mentioned 4 cases here. Okay, but it will. There will be several others to follow up to G, up to letter alphabet G. So first one is, we will put here, this is the alphabet. A to G, which will specify the lump size. Second digit, it's a number. Second digit is a number, and that number is also from 1 to 5, and it specifies the flowability of the material. Let us see how this is being classified. You see here flowability, right? Now we know that flowability, the measure of flowability is the angle of repose, right? So very free flowing like cement and dry sand, we put it at as 1. And here the angle of repose is 0 degree to 20. And similarly, this is very free flowing, then free flowing, average flowing, and then sluggish, and angle of repose, as you can see, 0 to 20 degree 1, 20 to 32, 30 to 35 3, 35 to 44, and this is more than this 5. So these 5 numbers specify the flowability of that particular material. So second digit, it's a one number, 1 to 5 specifying flowability. Okay. Then the third digit, it's again a number. It's again a number. And this time, this number is from 6 to 9. And this specifies the abrasiveness of the material. Let us see. Abrasiveness. Non-abrasive, if it is not not at all abrasive, then it is 6. Abrasive, like alumina, is 7. Very abrasive, 8. Very sharp, 9. So depending on the abrasiveness, this is being given as 6, 7, 8, 9, like that. Okay. So this is the third one. The third one number 6 to 9 specifying abrasive. Okay. Next one, fourth digit, it's again an alphabet from capital H to K. Capital H to K. And this gives the bulk density of the material. Remember, bulk density. I mentioned in the previous class that we will be dealing with the bulk density, not the density of the material. Okay. So let us see how this bulk density being classified. So bulk density, if it is light, that is up to 0.6 ton per meter square. This is what bulk density. Then it is age, and as it increases, like light, medium, heavy, very heavy, this becomes H, I, J, and K. So this gives the fourth digit. It gives the value of, it shows the bulk density of that particular. And the last one, fifth one, you'll find here again alphabets from capital L to Z corresponding to miscellaneous characteristics. We have seen earlier that there are several other characteristics also good on which the handling depends. So all these are being considered here. Just a minute. আমি ক্লাস নিচ্ছি তাতে নিয়ে বলছি ক্লাস করছি আমার এটা কমপ্লিট করে দেবো ঠিক আছে sorry. So let us see how we put the code there, right? Miscellaneous characteristics. What are miscellaneous characteristics? There are several characteristics it can have. Just for example, it can be a sticky material. It it can be a contaminable, it can contain explosive, okay. It can be degradable, it can be highly corrosive, it can be mildly corrosive, hygroscopic, oils, fat, and several other. These characteristics are also in this chart are given like this. So if it is, say for example, if it contains explosive, code is there. If it is sticky, code is N. Contaminable, P. So this gives the miscellaneous characteristics of that particular material. So one or more alphabets A to Z corresponding to miscellaneous characteristics. So this way, a bulk material is being codified with the help of this file. Maximum of five. I am repeating again. You can find that in some material, you don't find the five, all the five digits. This is because those digits are not that important for the I mean so for the uh, uh, bulk material is concerned. Now we will take some example and we will try to understand this codification. See here. First one is we will discuss some of this. Alumina, or what I should take. Let us take this cement, Portland cement, which is very common to all. See here, the code is A27M. You find that one particular digit is missing. Okay. So what is this? Let us see. Let us read the characteristics of this cement, Portland cement. First one is A. So let us go back to this chart. A. That means it is a dusty material. Okay. Fine. Second one is 2. That means the flowability is free flowing. It's free flowing. Okay. Then what do we have? We have 7. Okay. What is this 7? 7 the abrasiveness. 7 is abrasive. So it is 7. Okay. Then comes M. You see here, M is, let us see what M stands for. M. Contain explosive dust. Contain explosive dust. And what is missing here? Missing is the bulk density. Bulk density is not there in this particular code. So what you could find that cement Portland, whose average bulk density is this. This is being angle of repose is, this is just for your angle of repose is 39. So this is A27 and M. Okay. And as you can see here, what is this? Angle of repose is 59. So if this is like that, you can measure it for like this also. Where it is? Yeah. Average flowing angle of repose 35 to 40 degrees. So in that case, it will be 4. But it is not here, it has been considered as 2. Okay, forget about that. This is the average angle of repose degrees like that. Okay, so does not get confused in this. So let us take an example of another one, alumina. Okay. Similarly, alumina is B27M. Other things are remaining same. So B is, what is B? B is powdered material. Fine. It comes under category of powdered material where maximum one size is. So this is how we interpret a bulk material from their code. So this is how this is be protected. And similarly, exactly. Well, as I mentioned, which one is missing, which one is missing, because these are not that important from from our point of view, from a handling point of view. So we are not that particular code is not included. Okay. So this is how the bulk materials are being classified and codified. And remember, this particular one, this IS code, IS 8730197. I again repeat, these IS codes are very important from your MCQ based question. Okay. So now, with this knowledge of material, we'll move on to the next one. Okay, okay, fine. Okay. Now, yeah, okay. Now we'll be discussing principles of material handling. So what is this? What are all these principles? Why is this being required? Now, these principles of material handling, these are nothing but some reference given out of the practical experience for for selecting a material handling system. There are innumerable principles of material handling. You will find in the book. Okay. And it is also not essential that you follow all the principles to get a proper material handling system in your in your establishment. You will take the help of some of these particular principles which we will be discussing, and then you considering your functioning of that particular establishment, you will decide the material handling system. Now, as I mentioned, there are several principles, innumerable principles. But what we will be doing first, we will be considering those principles which have been mentioned in your syllabus. Okay. Now let me. Okay, just a minute. Let me take this one. The syllabus first. Well, this is the syllabus that you have, right? So you see here, principles of material handling. Okay, and it is being mentioned. Some 10 principles are being mentioned here. Material flow, simplification, gravity, space utilization, unit size, safety, standardization, dead weight, idle time, and motion. So we will be discussing all these 10 and also 10 principles, and also side by side we will be discussing some more principles also. Okay. So let us now go back to the topic. So principles of material handling. Okay, the word principle means in the context of material handling a prescribed rule or guide to accept procedures established through past experience, which is taken for granted or accepted as an authoritative by the practitioner. Okay. Okay. Uh, so straight away let us go for the different principles. So what is this? These are some guidelines that have been provided. Okay. Okay. Now, as I mentioned, it is not necessary that you have to apply all these principles or guidelines in selecting a material handling system for your establishment. Right? So that is why it is mentioned. Therefore, these principles are to be considered judiciously in context of the specific problem and to be applied to the care. So these guidelines, yeah, these guidelines has to be properly chosen. It's not necessary that you have to follow all the guidelines. All the guidelines will follow, will get followed for you. But you have to pick up the one that is suitable for your system. So let us start discussing these principles. First one is planning principle. Okay, so that is the first and foremost thing. All handling activities should be planned. It should be planned. Without planning, if you think about the handling system, no, there is no, you cannot have an efficient handling system. Okay. This is the most basic principle which is in line with the material handling equation. So what is that? Let us see the block diagram here. Yeah. You see, try to understand this block diagram. Okay. So material handling equation, a simple but useful way of planning the designing a material handling problem is described by the material handling equation. What is that? If the material handling if the material handling is necessary, then material plus move is equal to method. What is that? Why you should go for this material handling? Is it necessary or it is unnecessary? If it is necessary, then what type of material you are going to consider? First thing comes is the material, right? And then where you want to transfer the material. Where? Not only that, when, in which time you want to move that material. So, what type of material you want to move in which time and where you want to move it. So this material plus this moves gives you the how. Now the question comes, okay, you know that this material has to be moved to this to a certain place. Now how you do it? How you do it and who does it? And who does it? So material plus move is equal to the method. That's what it is. The material plus move is the method. Right? So this is going to be presented here. The planning starts with the question why at all the contemplated material handling uh, is needed. If the necessity is clearly established, then only a new handling system is to be considered. And next question is, what type of material to be moved, to where and when? Answer to this question leads to the method to be developed. How and by whom? By whom means whether it is by manpower or some operator. The material handling will be affected. In effect, the equation emphasizes the necessity of carefully analyzing both the materials to be handled and moves to be made before selecting a method. So this is what is planning. It's not that you start all of a sudden you start handling, but no, you have to think, you have to plan your movement, okay, to get a proper handling. So this is what is planning principle. Second one is system principle. Integrate as many handling activities as possible, encompassing full scope of operations like receiving, storage, production, inspection, packaging, warehousing, shipping, and transportation. So when you talk about the system, so all the activity right from the storage, production, inspection, packaging, warehousing, shipping, you have to put them under one umbrella, right? That means you need to integrate all these operations. Okay. And how you can do this? There are some suggestions here. Consider the entire scope of handling activity beyond the scope of immediate concern. Integrate operations into a handling system like processing, inspection, packaging, etc. Avoid, minimize intermediate storage. While designing a material handling system, the practice requirement of the supplier, clients, and transporters are to be considered. Allow necessary flexibility considering future requirement and these are some solutions by which you can improve your improve your handling system. So planning principle, system principle, and then material flow principle. Plan operation sequence equipment element to optimize the material flow. Now, I'll just try to explain it to you. Say you have this is 1, 2, 3, 4, 5, 6. Now this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now you are receiving material here. Okay. This is the workstations 1, 2, 3, 4, 5. Here when operations are being. Now your system in the plant is like this. From station 1, it should go to station 4 for next operation. Then it should go to station 6. Then it should go to station 3. And then it should go to 2. And then it should go to 5. 5. And then again back to 6. And then this is going down. Now you see, look here. If your argument is like that, this way, then you are losing a considerable time in transporting the material. First material going from here to here, then here to here, here to there, here to there, like that. But instead of this, if your system was like this, if your system was like that, that from station 1, material should go to station 2, from 2 to 3, 3 to 4, 4 to 5, 5 to 6, and then move on. In that way, you will just see your efficiency will have been better because you will be losing less. You can produce more in a standard in a given time. So this is what it says, the material flow. Plan operation sequence and equipment arrangement to optimize material flow. Okay? And to do that, to achieve this one, certain solutions also have been made, right? Eliminate obstacles from the material flow. Okay? Plan material movement in direct path. Keep related work area close. Combine operation to reduce material movement. Minimize movement of within the floors. Move bulky material. These are some solutions which have been given. Okay, I think I should stop now because we have the next class. So after the next class, I believe. Yeah, the next class. So let me stop here. We will record here. So let me